Now I am going to teach 12th standard physics lesson number 2 problem number 9. Calculate the current in the following circuit. From the circuit, applying Kirchhoff current rule at junction B. At junction B, here current I1 entering current I2 leaving from junction B, current I3 leaving from junction B. So Kirchhoff current rule states that sum of the entering current is equal to sum of the leaving current. So applying Kirchhoff current rule at junction B, we obtained I1 minus I2 minus I3 equal to 0. So this equation is coming from Kirchhoff current rule. Kirchhoff current rule states that algebraic sum of the current means at a point of junction equal to 0. So here current towards the junction, current entering towards the junction is taken as positive. So I1 is positive. Then current leave from the junction B taken as negative. So here I2 current and I3 current is leaving from junction B is taken as negative. So we obtained I1 minus I2 minus I3 equal to 0. So rearrange this equation, I1 minus I2 equal to I3. This is equation 1. Then applying Kirchhoff voltage rule for closed loop ABEFA. Kirchhoff voltage rule states that algebraic sum of product of current resistance in a closed circuit is equal to algebraic sum of EMF in that closed circuit. So applying Kirchhoff voltage rule, a closed loop A, B, E, F. So here algebraic sum of product of current and resistance. So current I3, resistance I100 ohm. So 100 I3 plus current I1, resistance I100 ohm. So product of current and resistance 100 I3 plus 100 I1 is equal to algebraic sum of EMF equal to 15 volt. So we obtained 100 I3 plus 100 I1 is equal to 15. From equation 1, I1 minus I2 equal to I3. So substitute this I3 value in this equation. So 100 I3 equal to I1 minus I2 plus 100 I1 is equal to 15. So 100 multiply inside the bracket. So 100 into I1, 100 I1, 100 into I2, 100 I2 minus plus 100 I1 is equal to 15. So 100 I1 plus 100 I1, 200 I1 minus 100 I2 is equal to 15. This is equation 2. Applying Kirchhoff's voltage rule for loop BCDEB. Kirchhoff voltage rule states that algebraic sum of product of current and resistance is equal to algebraic sum of EF in that circuit. So here current flows in a clockwise direction taken as positive, current flows in anti-clockwise direction taken as negative. So applying Kirchhoff voltage rule in a closed loop B, C, D, E. So here product of current I2, resistance 100. So 100 I2, then product of I3 resistance 100 I3. So here this is forward direction, this is 100 I2 is taken as positive, this is clockwise direction, so this anti-clockwise direction. So this current is taken as positive, this current is taken as negative. So EMF is in opposite, so that minus 9 volt. So we obtained 100 I2 minus 100 I3 equal to 9 volt. So from equation 1, substitute the equations 1 in this equation. We obtained 100 I2 minus 100 into I3 value from equation 1, I1 minus I2 equal minus 9 volt. So 100 I2 minus 100 multiply inside the bracket 100 into I1, 100 I1 minus into minus plus 100 I2 equal to minus 9. So 200 I2 minus 100 I1 equal to minus 9 volt. So rearrange the equation and write minus 100 I1 plus 200 I2 equal to minus 9. This equation 3. From equation 2, 200 I1 minus 100 I2 equal to 15. From equation 3, minus 100 I1 plus 200 I2 equal to minus 9. 200 I1 minus 100 I2 equal to 15. Multiply equation 3 into 2. We obtained minus 200 I1 plus 400 I2 equal to minus 18. 200 I1 plus 400 I2 equal to minus 18. So 200 I1 cancel. 300 I2 equal to minus 3. So 100 I2 equal to minus 3 by 100, 1 by 100. We obtained I2 equal to minus 0.01 ampere. From equation 2, 200 I1 minus 100 I2 equal to 15. 200 I1 minus 100 into I2 equal to 0.01. So my 0.01 equal to 15. So 200 I1 100 into 0.01, 1 minus and minus plus 1 equal to 15. So 200 I1 equal to 15 minus 1. 200 I1 equal to 14. So I1 equal to 14 by 200. So cancel two tables. 7 2s are 14. 100 2s are 200 equal to 7 by 100 equal to I1 equal to 0.07 ampere. From equation 3, I3 equal to I1 minus I2. I3 equal to, substitute the I1 value, I2 value. I1 value 0.07 minus I2 value minus 0.01. So I3 equal 0.07 minus plus 0.01. Add this equation, we obtain I3 equal to 0.08 ampere.